Out. Hi, everyone. This is another episode of Live Contract Reviews, and today we're recording in Zoom. So you might see a higher quality, and at least this is what I hope for. Today we're going to review a wNEAR contract that I updated from NEP 21 towards a new fungible token standard that we currently still developing. It's mostly finalized. The only piece that is not finalized is metadata. And this is fungible token specific metadata. So let's go into this. And I think this video will be great to actually understand the new standard and how it works. First of all, what is wNEAR? wNEAR is similar to Ethereum's wrapped is, and that allows you to represent NEAR token as a fungible token. So when you're writing a contract that interacts only with fungible tokens, you can use wNEAR and it will work the same way as any other fungible token. But under the hood, it's actual NEAR and represented one-to-one. So the way it usually works is you have two methods, one to deposit NEAR as a touch deposit, and that will wrap this NEAR and mint new tokens, essentially. And the contract will keep this NEAR on its own balance, but your account will get tokens. And the second is withdrawal. So that essentially burns the fungible token NEAR, the fungible token amount, and returns you NEAR to your account. Okay, so there is the structure of this contract is the following. We essentially have three standards that are representing a fungible token standard. So it's composed of currently of three standards. We have a core API, originally was in 141. I think latest in 146 actually. A storage manager with generalized account registration to provide storage allocation, variable storage allocation. So the way it works is because NEAR requires you to keep some amount of NEAR for the amount of bytes that your account keeps. So for example, you deploy a contract, you need to lock some amount of NEAR, given a price per byte multiplied by the amount of bytes you occupied on this account. So when you deal with a contract that have multiple users and multiple accounts, which is majority of contracts are going to be like this, then you need to think about Sybil attack by the users that will try to drain your available storage. So let's say you have 50 NEAR on your account and you use 30 NEAR for storage. So an attacker can try to block your contract from taking more transactions by pre-allocating storage in your contract state by issuing a ton of transaction that increases storage. In fungible token example, you can basically, if there was no account registration or storage managing, then you can send one yocto NEAR to like a million of implicit accounts, and that will increase the storage more than amount of gas you would have to burn for this. So you would pay less in terms of NEAR than what you will use on this given account. Even with 30% gas refunds, you will be able to drain the account. That's why we designed a standard that allows you to pre-allocate NEAR for your balance that would be used only for storage. So essentially, you can somehow like say, hey, here's wNEAR that you can use for my storage on this account. We'll get to this. Finally, the third one is a metadata specific to the token. We didn't want to put it into the core because this metadata may evolve. So for example, we may introduce an icon there that's not present yet. And the new fungible tokens metadata will include it while the old one does not. We cannot really change the previous NEP once it's finalized, so it has to be a new standard. And another method, file is wrapNEAR, so it just has a logic to wrap and NEAR and unwrap NEAR. And finally, some internal methods that we use for fungible tokens, plus some helper methods. Okay, so that's a high-level overview. The way we do imports are like this. We use some crates that has to be exposed as pub use crate that export all methods to our module, and some crates that don't need to be exposed outside of this module don't have pub. Then modules, and I like now to rename all of my contracts to just contract instead of like giving it specific name. So because it's a singleton, it makes sense to call it a contract. So like every contract I use, I will call it contract now. So it uses the current live NEAR SDK, not the one that we'll publish. So it doesn't have the helper, for example, for panic on default. And it has three methods or three arguments. So first is a lookup map, is a map from account ID to balance. If you remember our previous fungible tokens, I used hash in the past because it was fixed size and it saves amount of bytes if your account is longer. In this case, I decided to not do this because it will help you to, if you want to get all balances of the wrapNEAR, you can still do this by querying a state of the contract. So you cannot iterate on a contract through the view calls. What's up?
So you would look it up externally by using the state API with NEAR CLI?
Yeah. It's similar how we use view methods, right? You usually don't need to iterate on it. Like view methods are designed, in theory, they should be designed to be called by other contracts. But in this case, we use view methods mostly externally anyway by calling some public RPC endpoint. So when you query in a state, you probably want to also be able to like query this and parse it later. If you hash the account ID, then you cannot do a reverse lookup unless you use indexer to figure out who created this hash. Plus 32 bytes. Well, yeah. So the difference here is account ID is a string, so it's not fixed size, so it's 64 bytes maximum for the size of the account plus 4 bytes for the size of the string. So it's 68 bytes instead of 32 bytes.
Maximum.
But we don't need maximum, yes.
Like the average account length is probably going to be less than 32.
Yeah, but I will still charge every account for full size to avoid small complication, but it's up to
sure.
Yeah. So yeah, then total supply is the amount of NEAR that is minted, so holded by this account, wrapped into the tokens, and it's variable for this fungible token. Finally, account storage usage is a constant that I compute at the beginning of the of at the initialization. So I basically create one fake account, and then I store it. I calculate the storage, and then I remove it from the storage. And here's how I do this. So I get the storage. I create this new account, which is I'm using unsafe. I don't know why. Then I inserted it into a map. Then I calculate the storage that it took, and then I remove it from the map, and I return. So I initialize my contract. So what happens here is it basically just puts a string straight without having to do from UTF-8. So it doesn't need from UTF-8 because it's already UTF-8, because I know about this. So just a way to initialize string. I probably can do string from and like put all this 64 A's there. And that will let me simplify this a little bit, but I'm afraid that I might make a mistake. So our total supply originally 0. So when you initialize this, we don't really need any total supply because no one owns any wNEAR. Okay, let's first go to wNEAR. So this is two methods unique to this contract. They allow to deposit NEAR, to withdraw NEAR. So first, both of them are payable, even withdrawal. And this is the security feature that we currently use until wallet and our wallet SDK supports this security feature on an access key level. So restricted access keys at NEAR cannot call a method that requires a payment. That prevents someone to create an access key to this particular contract and issue a transfer, for example, from their DApp. In order to do this transfer, they have to call the wallet, and the user has to confirm the transfer. Now, when we design a wallet, we can embed certain APIs there, like we can embed FT transfer and FT transfer call to be like a hard-coded methods that we know. And we say, like, okay, it seems like this is a fungible token transfer. So this particular approval is not just a simple function call that requires 1 octal NEAR. It actually going to transfer tokens to this particular account. And if you see this, you're like, maybe I shouldn't approve, like transfer all my wNEAR to like Chad's account. So, okay, so this is the idea for payable. So deposit works the following way. You deposit the amount that you want to wrap. We say this should be a positive deposit. Then we grab the predecessor. We call a method internal deposit, which increase the amount on your account, deposits to your inner account. Then we increase the total supply, and we emit a log saying deposit blah NEAR to blah.
Is amount in Yocto?
Amount in Yocto, yes. And
Total supply is also U128.
Yes. So what's an internal deposit? We basically say, give me account, give me current balance, and then we call expect, which saying if the account doesn't exist, let's panic. If the account is not registered, the deposit will fail. All this NEAR deposit method will revert. Then we use overflow and check to add a balance in case there's a balance overflow, which is unlikely for this contract. But if you're implementing some other fungible token contract that will use this as a helper, or like we port it in nearlib, it's good to have this check here to provide a proper bank. And then we insert account back with the new balance.
One small Rust question
Sure.
while we're here. What's the pub crate?
It's public within the crate.
Yeah, so crate in this case means our module, so this stuff. So it's only going to be visible to this module, but not exported
The
from
module being
out.
the contract module. Yes, or like all the code in this code base.
Yeah, all in SRC.
Thank you.
So I have two helper methods here, a third one Yocto. It means.
So I do have a question though about the use of the crate. Is that just good practice? Because if you were to, import this from another one, you wouldn't see it because otherwise it's still hidden because there's no macro on the impl, right?
Yes, but for example, if you do this method, that will be public. So
yes.
a wasm compiled method will actually export this. But if I will hide it from pub crate, so make it fully private, then for example, other
I see.
modules will not see it. But I wanted this to be public, but not fully public.
Say that again. It's public in which contexts?
So it doesn't export this method from the contract towards the contract. So if I will, for example, implement this like this, then when I compile it towards wasm, this is a public method that will be exported to the WebAssembly contract. So I will be able to call.
And you'd actually be able to call it on chain.
Yeah.
That's like a view method, which makes no sense.
No, it's a change method. Like every method is a change method by default. It just, like it's tricky. So
yeah, I guess it would be.
So
because you can attach a deposit. So, but it doesn't change anything.
Yeah. Still, it saves some bytes that we don't export it. Okay, and now withdrawal works somewhat similarly. We first assert one wNEAR. So you need to attach exactly one wNEAR to this method. Otherwise, it would fail. So we don't want to attach more. We don't want to attach less. Otherwise, it would be insecure. Now, we do internal withdrawal. So we decrease the amount from your account. We remove the total supply. And we emit a log saying withdraw blah near from given account. And then we issue a promise to this account to transfer the amount of near you wanted to withdraw plus one wNEAR that you attached to the deposit. And we return this promise. So that's a simple wrapped methods that allows you to mint and unwrap, like burn tokens to receive near back. So now let's go back to a more complicated method, which is a fungible token core API. So here's a trait. Trait is like an interface in other languages, and that's a common trait. It just defines methods, but do not implement them. So there's 4 methods that are required for core API. So first one is a change method called ft transfer. It transfers the amount from a sender, which is a predecessor, to the receiver, the given amount, and you can put an optional memo. JSON works the following way. If you don't put this key, like you don't have memo key, then it will be option none. And if you put a key memo, then it will be options some. So it's going to be some string. Memo, you can just use it to give some memo associated with this transfer. So for example, like I'm paying you for lunch, and here's a memo. Now, second
Venmo on the
method
blockchain.
Yes, it's a Venmo on blockchain, public feed. Now, FT transfer call, it has an extra field called message. And this is similar to Vault. You're basically gonna give this message to the receiver. And the receiver will have to tell you how much funds it don't want. So like return them unused amount. And that returns a promise. Now you have a total supply and a balance of an account. So it returns 0 if the account is not registered, instead of panicking. This is the trade on the receiver side. This method does not implement, or this contract does not implement it, but it just defines FT on receipt, on transfer. So it gets us who sent it, the amount, and the message. And you need to return the unused. So you need to return unused tokens that should be returned to the sender. The idea is a Uniswap, for example, only needs 450 tokens out of 500 to account for slippage. And then the rest 50 should be returned to the user if the price didn't slip in between. Finally, this is a wNEAR SDK bug. We have a resolver. So this is for the ourself, for the callback. And I also need this trade to actually implement it. So right now I filed this issue on GitHub for wNEAR SDK. Is basically X contract is actually consuming this trade, which means the trade stopped being a trade in our contract. That's why I just copied it here, because I also want to implement it. And that's a callback. So the way we implement a core API.
That didn't make sense, by the way, but
it's the
that
macro.
didn't make sense to me.
The ext contract macro is taking in the AST of the trait, and then it's constructing something different. And so so then that's why you have to, like, you know, say it again, so that then the other things that come after it will be able to refer to that trait.
One's looking from the outside as a cross-contract call. The other one's looking from the inside.
Well, so I suggest we refactor X contract call. So it should introduce some kind of a macro, a module, or like a method, whatever, that will initialize this. It will basically, when you call it, it will return you an instance that implements this trait. So you keep the trait, but you also have a new instance that all methods for this trait that will return a promise. So it will be much nicer API. I think I'll be able to work on this soonish.
You're saying you can reduce it to one instance of the trait. Is that what you just said?
Yes, but you also will simplify this particular call. Like when you do a cross-contract call, it will be much better API that can be visible. So as we discussed before, you would do something maybe like this. So you would say who you want to call, in this case, a receiver. And then you can do FT transfer. And this FT transfer will actually be a trait implementing, like this piece is going to return you an object, an instance that implements this trait. So when you call FT transfer, you actually call in this particular method, except this API will be different. It will be a promise. So maybe it's going to affect it slightly, or like it can wrap it into promise of value. Anyway, we can figure out how to actually make it work.
One other, I'd like to restate why we have both of them up above. If you only had, the first one is just so you can do this cross-contract call here, ext fungible token receiver. Is that correct?
Yes.
That's what the ext contract in like trait is
Yeah.
for. And then the second one is for lets you do what? If you didn't have it, what would break?
It just
The
puts it
second
back.
one let me do here. I implemented it.
Okay, thanks.
So
Okay.
the implementation of this is actually of these two methods are nice in terms of, so I do assert one yocta, then I do my input, and then I issue internal transfer. Here I do the same for lines, but I also do in a promises that I'm gonna call. So I'm calling a fungible token receiver to get on transfer. I pass in sender ID, amount, and a message. Then the receiver is receiver ID, not deposit, and I attach enough gas, all the remaining gas to the receiver. And I estimated I'll consume 30 teragas for this call. Well, actually, no.
30.
Well, yeah, for this call, because I'm attaching 5 teragas here, and the rest will go here. This call cost 5, this call cost 5, and this one then right now costs 10. So it's 20 for the promises, and 5 for this, and 5 for our own. Now, what we're doing is okay, and two other methods are fairly simple. So total token ft total supply just returns total supply, and balance off we get the account and say either give me a balance or 0. And internal transfer does the following: it checks that sender is not a receiver, then internal withdraw, internal deposit. We say, oh, here's a transfer happened of this amount from here to here. And if there was a memo, we say memo of this. And we actually wrap this memo, so it's not just like a pure log that you can dump from the contract. It needs to start this memo. Okay.
Why does it matter that it's not a pure log?
Well, if someone depends on this log, on the log data to prove that the log exists, then you can just say, oh, I did a transfer of 1,000,000 tokens. And then you prove this, that you did this transfer, but you only transferred 1 token. So if you rely on logs to prove something, Memo can fake it. All right. Okay, finally, resolve transfer. So this one fairly complicated, like more complicated than used to be, because we handle that the account can be deleted during the FT transfer call. Both accounts can be deleted. The sender account can be deleted. The receiver account can be deleted. And the receiver also can try to like return some bad value to you. It can also panic on this call, and it can overspend the tokens that it had, so it cannot do a refund. All right, so here's what happens is we call promise result. So instead of handling it using a callback macro, because callback macro will panic if the callback panics, but we still want to do a refund. Then we do promise call, so not ready doesn't exist. Successful. means the promise to return value has succeeded, and failed means the promise has failed. It means we should refund entire amount. So if it succeeded, then we parse the value, or try to parse the value, because it can return me some fake data. If it's non-parsable, it's a misbehavior, we refund the full amount. If it's parsed, then we return a minimum of amount and unused amount. Because let's say you can say, oh, I got 10, but I will return you 20. That's not good. So you can at most return amount. So we got the unused amount. We want to refund. If it's positive, then we will try to do a refund. So we try to get a receiver balance. But receiver can be deleted. In between, it means the balance is 0. For us, it's not different whether receiver was deleted or it has a balance of 0. So if receiver balance is positive, then there is a chance we can do a refund. So we calculate how much we can refund. We'll try to refund the maximum amount allowed. So we will try to refund either receiver's balance or the unused balance, whatever is available and needed. Then we say, okay, receiver, now you return the refund amount. We do not need to use internal withdraw here because we already verified the receiver balance is positive, so account exists. So we don't need to read this value again. Now, the interesting part comes in when you're trying to say, well, where this refund should go. So we check if the sender actually still exists. So sender can actually also delete their account in between to like try to break our contract or like some other API. We don't want this to happen, so we want to handle it carefully. So we check if the sender account exists here. Then we say, okay, that's a best case scenario. Boss account existed, refund happened. Here's the balance. So you got your sender balance plus the refund amount. And we say refund of this amount from receiver to sender. And we say how much money the sender actually spent. So this is the amount minus the refund amount. It handles this like corner cases nicely. Okay, and if the sender was deleted, so there's two things we can do in this case. We can say, oh yeah, the receiver, you can keep the tokens, don't need to refund it. Or we can instead actually burn it. So in this case, we decided to burn these tokens, which is currently will be locked forever on this contract. The wNEAR will be locked forever on this contract. But in theory, we can update the implementation of this contract. So the owner of this contract can withdraw gas fees that it earns for the transaction, for the good of the system. So we say sender's account was deleted. We decrease the total supply. We say the account of the sender was deleted just to tell what's happening. We burn this refund amount. And if unused amount was not positive or receiver balance was not positive, then we just refund. We say the sender spent everything, so there's no refunds. So this is how the FT transfer call works. It's optimistic that the receiver is properly implemented and the sender is not malicious and the receiver is not malicious, but it still handles it properly, never panics here. No matter like what you do. So FT transfer call always gonna return you a value and it's not gonna panic. unless you run out of gas.
You're saying it's optimistic
Here
because all these checks happen after the fact in the callback.
Yeah. Yeah, after you like call the receiver to say, okay, go wild with your deposit. And the receiver can essentially block this call by doing like a bunch of stuff, and then only after this returning a value. So it can like any state can happen in between. Okay, so this is a core fungible token API. It's going to be similar for all fungible tokens, and it's going to be part of the library that Ilya started to work on, called like wNEAR lib or something. So you will be able to something like drop and method or drop something like pub fungible token on your core contract structure, and it will have all the logic there, or somewhat like that. So we still haven't solved the.
Would that make it be nested under like fungible token dot function name, or will they be top level?
Yeah. Yeah, I think it will be nested. Well, meta is going to be public, like as is, because the interface, but the value is going to be under this fungible token. All right, so we have 15 minutes. Let's quickly go through metadata first. Metadata right now, I call the trait fungible token metadata provider. It returns a fungible token metadata with a call to FT metadata. So currently it doesn't have a version. Maybe we should add a version here as a top field in the JSON. So it would be something like a version, and you will say version of the metadata, or like meta version is something like 01, and it means it follows the standard of this metadata. So if you update a standard later, when you parse it, you're like, okay, which version it is? I see. And then you can pull all the necessary fields for this version. So for example, if icon link or like icon URL doesn't exist, then we move there. Also, I asked to rename reference because ref is a keyword in Rust and it complains. You can still fix it by doing further rename. I think you can do something like this and then do further name, something like ref. And I don't remember the exact syntax, but it works somewhat like this and it will be fine. But you can just call it a reference and don't worry about this. So I used give the generic name, wNEAR fungible token, symbol wNEAR, and reference to the source code where it's located, and 24 decimals. This is a wNEAR decimals number.
Should you instead point to a release instead of because master could change?
Yeah, good point. Well, I didn't push it, so it's kind of problematic to get my commit first and then.
Yeah, rapid, and then there's a chicken and the egg kind of issue.
Yeah.
I guess you could make it a branch, and then it is what it is.
You can
storage manager. So this is storage manager is essentially a generic interface or standard to manage a storage per user account on your contract. And here's the interface. It has.
Can I ask a question quickly about the metadata? Is there a way to update the metadata?
Yeah, yeah.
Like, will you be able to update it later after it's deployed?
Not for this contract. So it's hard coded, it's static.
Okay.
Yeah, I mean, ideally, we could have publishing through a contract too.
Yeah, you can basically like pass it from self and then just give the reference from self. So when you initialize this, you actually put the reference there. So that way you can solve the chicken and egg problem. All right, so storage manager, it has 4 methods to change methods and to view methods. So storage deposits, it works like deposit near for wrapping near, somewhat similarly. You tell which account should receive it. It's an optional field. If it doesn't exist, it means you want to deposit on your account, the predecessor account. And storage withdraw tries to withdraw available amount from the storage balance. And storage minimum balance is the minimum amount of NEAR you need to provide for the storage to register your account. So below this, the contract will reject it because, for example, just to store the amount of storage you have. So for this particular balance, you need the account size. And finally, a storage balance off gives you a balance of the allocated for storage for the given account. It also doesn't panic now. We use the structure, which provides 2 values, total amount of balance allocated in NEAR for this account and available for withdrawal. So like this amount of NEAR that is free and not used by this contract. So let's look what happens to get more understanding. So since this contract is fixed size, it doesn't need variable amount of tokens. That actually enforces you when you deposit for something. It's saying you need to attach exactly minimum balance, storage minimum balance. Like this. So we get how much you attached. We verify that the storage minimum balance matches the amount you attached. Then we say, okay, what's the account we should deposit this to? If it's this essentially casts the valid account ID to account ID. And if it's not provided, then we do predecessor, so your own account.
Can you throw the storage minimum balance into the error message that's thrown for usability?
Maybe, but it requires like it will be thrown from assert_eq. Assert_eq provides the values that it mismatched. So it will say you gave that is that, but you need to give minimum. So it will return this value as well.
Perfect.
When you unwrap the panic. So you get the account, we do an insert, and then we verify if it was already a value there, then we panic saying, oh, well, the account was already registered. It's already registered. Take your money back. So we do not work as a standard expects, like you cannot increase the balance above certain value. And then because the balance became your balance is 0, you can actually withdraw it. So the only way to withdraw storage is when your token balance is 0. It requires you to drain your account first in NEAR. So your total became some amount and available became some amount. when you receive some tokens or deposit near, then the balances changes. So if your account exists, you have some balance. Then we say the total amount of the balance you have is a minimum balance, but the available balance is either 0 if the balance is positive, which means you cannot withdraw storage because you have some positive near account balance, like corrupt near token, or if your balance is 0, it means you can safely delete your account, so your storage is available. Now, if your account doesn't exist, we say your total amount is 0 and available amount is 0. Okay, let's look at the storage withdraw.
Can we look at that one more time?
Yeah.
Available if balance is greater than 0, then it's 0.
So this is a token balance, not a storage balance. If your token balance, near token balance is positive, it means you cannot withdraw your storage deposit. So
This is what's available for you to withdraw.
Yes.
Okay.
It's like available storage. So let's say you have like 1 kilobyte of storage and you used 200 kilobyte or 200 bytes, then available will be 800 for the normal case. In our case, we used full amount when your balance became positive. And we say you cannot withdraw the storage. Make sense? You probably need to get more context from the NAP. So this is NAP 145 that talks about this. And that explains the logic behind it.
Yeah, I'll take a look at that. Thank you.
And now withdrawal works the following way. You say how much storage you want to withdraw, or like how much amount of near you want to withdraw from the storage balance. And well, that's actually a bug. Oh no, it's not a bug. So the storage withdrawal also requires you to issue so everything that deals with near or the positive value, we say this is a security method. Then we need to say attach at least one yocta near. We say how much balance you want to withdraw, and the only way to withdraw is entire balance because we don't keep fractions. So we're saying the withdrawal amount should be exact storage minimum balance.
Then why even have the argument?
Because the standard is more generic, so it's not only for fungible token. And we get your account, we check. Well, we actually delete your account. And then if the balance was positive, we revert by panicking, saying, hey, your account has positive token balance, which means you cannot close your account. Otherwise, if your account existed, but the balance was 0, which is what you hope for when you do this, then we return you amount plus 1 yocta near that you attached. And we return now the balance is 0, 0. And if you don't have account, you cannot withdraw this. So that's a withdraw. So that's like a subset of the API that provides. So yeah, we basically looked at the 3 standards: so core API, metadata API, and storage manager. And that's it. So for this token, I don't have tests yet. This all tests. They probably gonna fail because of different API that was there. And I want to use simulation tests instead. So I will keep it for now like this in draft until, but we can actually test it in testnet eventually.
Awesome. When are you thinking this will be published?
What exactly? This contract or like
Contract with
bullet?
simulation tests. Yeah, like on GitHub for people to reference.
So I have the repo published already. It just needs to add simulation tests and maybe fix.
Is it in the core contracts repo or the?
Yes, it's a core contract. So just my local repository is still initial contracts. But yeah, it's in core contracts. I removed old wNEAR to, or moved it to NEP 21, and this one is currently 141. We still don't have a version
46, I assume.
Yeah, full fungible token name that you'll give. Something like 1.0. Yeah, let's wait until we can actually publish a new one, then remove some boilerplate, maybe move all this logic into nearlib, so it's also much simpler. So
where's nearlib live?
I'm not sure.
It's currently a branch
Probably
on the
separate.
SDK, but it might move to a different crate or a different repo.
You said Ilya is working on that?
Yeah.
He started this.
And it's like, I'm imagining it sounds similar, or like it has some similar functionality to something like Open Zeppelin, where you can import.
Yeah.
Fantastic, love it. But Rust specific, not, or will it be like raw WASM?
Yeah, it's.
I mean, ideally, if we embrace interface types, it could become, broad, but until you can like import a Rust into assembly script, then no.
I mean, it's still great.
Yeah, and assembly script uses slightly different storage model. It uses JSONs for balances. And this one uses bars for balances, so they're like different in terms of what it produces. So okay, thanks everyone for listening. I'll stop.